In this demonstration, I'm going to use a little example house on SketchUp to explain kind of the basics of how we go about drawing and documenting buildings. And we have to take a built reality or a future built reality and define it on representations that go on sheets of paper or on a computer screen that enable people to build the project. So what I've done is I've modeled a simple house in SketchUp, and the first and most basic drawing, probably the primary drawing of architectural design, is the plan view. And the plan view, I'm just going to click on this, is a horizontal cut plane, and you're going to see that coming down into the picture. There it is, and it cuts down the building. So when you cut a floor plan, you're typically cutting, I don't know, somewhere between 4 and 5 feet above the ground, maybe 6 feet. But it's above 3 feet because that's kind of where your kitchen cabinet heights are for your lower cabinet. And it's below, definitely below 6'8". I don't know if there's a really right answer on exactly where you're cutting your floor plan, but you don't want to cut above 6'8" because then you're cutting above a residential door and you wouldn't see it. So that's your floor plan view. So you're cutting perfectly horizontal. That's your cut plane. Now for the actual floor plan we don't draw them in 3D view like this because you cannot. So if I printed this out on a piece of paper and I took my ruler and I scaled this and I scaled that, it would scale at two totally different dimensions because it's not to scale. This back one is foreshortened because of the perspective effect. So when we make a floor plan, we look straight on it. So it's almost like where this cut plane is cutting through the walls, you can see that the line's a little bit darker. If this was like a big sheet of glass and I would trace this on the sheet of glass, there'd be no distortion because it would be like a one-to-one relationship. If I measured an inch on that sheet of glass, it would be an inch on the wall. That's the beauty of floor plans, because since they're totally square and perpendicular to the world, there's no perspective foreshortening, so you can scale off of the plan. So everything's in its proper scale and relationship. So let's show you how a floor plan actually looks. So we typically draw our floor plan square to the world at a 90-degree angle, and the door swings graphically, sometimes they're drawn 45, most of the time they're drawn 90 degrees open. The windows might be drawn simpler, just graphically. When you cut through a kit, I've got a tall cabinet in my little example. You probably wouldn't show the drawer and everything when you cut. That's just because I'm using SketchUp for an example. And an architectural drawing, this would just be a simple box. But that's our floor plan view. So we can have so on a little house like this, if I had a basement, I could have a basement floor plan, a first floor plan. This is only a one-story house, but if I had a two-story house, I could have a second floor plan. And then if I'm looking down at the roof, it's the same exact concept, except I'm not cutting through anything. So this piece of glass, or this section plane that we're talking about, if I moved it up above the house and I looked down, so now let's go to the roof plan. Okay, so the roof plan view is kind of the same as a site plan view. So if I wanted to show my driveway and my walks and where my trees are located, I would do a floor plan view, but I'm not actually cutting through anything. But it's still, there's no perspective foreshortening, there's no distortion. So if I measure this dimension on my roof plan, it will be exactly what that is in the real world. So that's why plans are so important for construction purposes and for planning purposes. So in addition to the section cut, so there's two kinds of drawings we use when we cut through the building. With a horizontal cut, it's called a plan. So what we're doing is we're cutting through the building horizontally and we're looking straight down at it. And then in a version of that is a reflected ceiling plan, which is if you cut the floor plan and you put a mirror on the floor and you look down on it, you would see what the ceiling was reflected in it. So that's how you draw what the ceiling is on a floor plan. And the other kind of section would be the section that you cut through the building either to show the spaces or to show how the building's constructed. So let's show you an example of that. So now you're going to see the section plane coming into the view here. And the way they explain which one's which is like if you have a rectangular building, if you're cutting through the short way, it's the transverse section. If you're cutting through the long way, it's the longitudinal section. If you have a square building, I don't know how they pick which one is which because you wouldn't be able to tell the difference between one way or the other. But a section is a horizontal cut through the building that, again, if I trace this, this is perfectly to scale when it's drawn square onto the building. So then this would be a longitudinal section. So it's the same thing, but except the section plane comes in from the long side. And so I can either do a design section that shows my spaces, or I can kind of leave that kind of blank and just show exactly how the roof attaches to the wall, kind of a construction section. Now you notice I didn't draw this with a basement, it's just sitting on a thick slab. You'll also notice that the section showing me that, even that there's no ceiling on this little bathroom here, and there's like a vaulted ceiling in my house. So that's the difference between the two kind of planes, the section cut plane, which is a vertical cut, and the plan cut planes, which are horizontal cuts. So now we're going to show you how okay, so what I did is I copied this house here, and now we need a way to show the elevation in a way that's square to the projection plane so that everything is still to scale. So what we do is that if this is my piece of glass, this is what the projection plane can be visualized as. If this is the piece of glass, I'm taking that elevation, I'm square to it, and I'm just drawing the lines out straight, perpendicular to the building. And where they hit that piece of glass, then like for example, that line's coming from the ridge of the roof, this line's coming from the top of the fascia, this line's coming from the bottom of the fascia. And obviously there's a line that connects up from there to there, and I can draw that up. And then I can draw this line all the way over because it runs over, and I can draw the ridge line all the way over. So these drawings, these lines out on the plane or the piece of glass are what my elevations are, and these are all to scale. Now the only lines that aren't to scale are, like for example, this line here. If I wanted to know how high, what's the distance from here to here, I could not measure this on the elevation because you see there's some perspective foreshortening there. I would have to get that distance from the elevation going the other way on the front or the side, the gable end elevation. So here's, SketchUp has a way that you kind of turn off the perspective. So here's taking that 3D and making it a side elevation. So you see what happens. It's square to the world. There's no perspective effect, and that's called an elevation. So this would be the back elevation. Now you'll notice on this one here, this dimension is to scale, right? Because it's square to the projection plane, and there's no perspective foreshortening. So that's the basics of a orthographic drawing. So the plans, the sections, and the elevations are orthographic, which basically means when you look at them, you're looking square onto them. You're not looking at them from an angle. So then there's a way to look at drawings, the 3D reality with 3D drawings. And one of the ways is called Parraline. And in a Parraline drawing, you turn off the perspective effect, and you can it's still to scale. You can measure this, but it doesn't look realistic. So this is more used probably in maybe product design or mechanical drafting than it is in architectural. There's two different kinds. There's isometric, where this angle here is 30 degrees and 30 degrees, and then there's axonometric, where typically it's 45 to 45 or 30 to 60. So these are more to have a 3D drawing that still is to scale, but as you can see, you wouldn't show this to a client because it's not a realistic. Your eye knows that this is not the way your eye perceives things. Now, the last way of looking at things is the way your eye really does perceive things. And it took people many centuries to figure out the rules of perspective, but once you figure them out, it's really pretty neat how that works. The reason they couldn't figure it out is like if you're out in the middle of the woods somewhere, they didn't have any like regular geometric things like railroad tracks or big tall buildings or straight streets that they could see the whole vanishing point. They were out digging around in the dirt, running through the woods, and there was nothing really that gave them the clue that reality is set up with these rules of perspective. So here's what so a 1 point perspective is when you look square on to an object. So if you stand in a room and you look square at the wall, what you're going to see is all the lines that come out towards you will vanish back to a certain point. So if your eye, so in this case, this line, this line, this line, all these lines are going to vanish back to a point. So if I draw this line down here and that line down there, that point is the vanishing point, and that's where my eye is. So that's a 1 point perspective. A 2 point perspective is when you turn so that the front plane of the building or the object is not square onto you. Now you have two vanishing points. I'm looking totally horizontally at the building, so my vertical lines are vertical. But you'll notice that all these lines vanish out to a point to the left, and all the lines going the other way vanish out to a point, it would be off my computer screen to the right. And those vanishing points shift depending on what angle you're working at. So you can practice looking at this. What a good way to look at this is to trace actual photographs and figure out where the vanishing points are. Now so this is the 1 point and the 2 point are simplified versions in that they don't have any perspective effect on the vertical lines because we're assuming we're standing. If I'm 6 foot tall, my eyes are at 5'6". I'm standing and looking directly straight out at 5'6", so that way the vertical lines are automatically vertical. Now the reality is we often are looking up a little bit or down a little bit, and that's a 3 point perspective, and that's really what reality is when you, for the most part, when you look around. So in this case, I'm kind of down on a worm's eye view and I'm looking up at the building, and you're going to notice that these vertical lines are going to converge at a vanishing point way up high. And a great way to check this out is to go on the internet and find a picture of a skyscraper where somebody took a picture of a skyscraper from the ground looking up at it, and you're going to see all those vertical lines converging up to a point. So hopefully this gives you the basics of the kind of drawings and the kind of views we use to describe the built reality.